All right, guys, let's go ahead and answer the warm-up questions and then get into our notes today on graphical relationships. So this is kind of a review of what we talked about yesterday with regards to the different variables that you have when you conduct an experiment. And I told you also have to be designing experiments as well. So it says, consider the following question. How does the height from which an object is dropped determine the time it takes to fall? How could you test this? So let's start there. All right, yes.
Drop a ball from different heights.
Okay.
And see the different times.
Okay. So she said drop a ball from different heights and see the different times it takes to fall. Perfect. So in that scenario, did you have a different answer or was it pretty similar?
It was pretty similar.
Pretty similar, okay. In that experiment or in both of their experiments, and hopefully yours looked similar as well, what would be your independent variable? The height from which you drop it. Okay, and then your dependent variable would, of course, then be the time that you would measure for it to fall. What are some things that you might want to control in that experiment? Okay, yeah, the weight of the ball. I heard gravity. Sure, we can't really control that one so much. If we're doing it in the same location, though, on Earth, then theoretically we have the same gravitational field at that point. But sure, you wouldn't want to do one test at one location and another at, like, in a valley and the other at the top of a mountain. It might be slightly different. We don't know. So performing the experiment in the same location is a good idea. Using the same object is a good idea. Different things that could potentially affect the amount of time it takes to fall, we want to remove those so that the only thing that could cause the changes, if there are changes that we see, would be the height. Okay, and that way we have valid results. So again, this is what we talked about yesterday, and you do need to be able to think about how could I test this? Could I write a procedure? Because that's what you're going to be doing as we move throughout this class. Today you're going to be doing a mini lab, and the procedure is going to be written for you. But in future labs, as we move forward, you're not going to have a procedure. You're going to be told, hey, how would you do this? And then you would have to write your own. So just keep that in mind. Just as a reminder before I move into the notes, you do have homework. That skills review packet is still due on Monday. You have those 2 assignments in the textbook in Mastering Physics. The intro is due today. The primer is due tomorrow, so don't forget about those. And then we're going to be doing an activity today, although that one's not going to be homework specifically tonight. We're going to be working on it in class again tomorrow, but you'll have that as well. We are going to take some notes today on graphical relationships because yesterday we didn't just talk about experimental design, we talked about graphs and what makes a good graph. But today we're going to talk about the different types of relationships we will see in those graphs. And so the first is really no relationship at all. Okay, I gave you kind of a ridiculous scenario here, which is how does the Scoville rating of a pepper affect my height? It wouldn't. I'm not going to get taller or shorter because I ate a pepper, which is why I picked this kind of ridiculous scenario. But it is possible that when you're testing something, that particular variable has no effect whatsoever on the other. Maybe you're testing something like this, spiciness versus height, and if you are, then you're going to get a graph that looks like a horizontal line because no matter how spicy it is, my height remains the same. Okay, and so if you have this type of scenario where you have no relationship, you would say that the y variable is independent of the x variable. They don't affect one another. And that's what this says down here. Changes to the independent variable do not affect the dependent variable. The equation of the line that you would get in this type of graph would just be y equals whatever number that y-intercept is. And so in this case, it would be height equals, if it was my height, 173 centimeters. Would be kind of what I would expect to see for my equation for the line, and yours would be whatever your height is. But again, that's the first type of graphical relationship that you need to know in this course, is that maybe there isn't one. Okay, maybe mass doesn't affect the falling time of an object. Okay, we'll talk more about that later. Maybe mass doesn't affect the period of a pendulum, whatever. If that's the case and you're testing something like that, what is the effect of this variable on this one, then your graph is going to look like that. And then that's the conclusion that you're able to draw, is this has no effect. And sometimes that's what your data looks like. The second type of relationship that you need to be aware of is a direct or linear relationship. This graph is exactly what I would expect to see for something that is directly proportional. In this example, I'm using how do the number of hours I work affect my paycheck? And for me, this isn't true, but if you're an hourly employee, this is exactly what your data would look like. If you work more hours, you make more money, and that should be the case in a directly proportional way. The two variables have a direct connection, so that if the value of x is changed, y must also change by the same proportion. If I work twice as many hours, I should expect twice as much pay. Okay, the equation for a direct or linear graph is going to be in the format y equals mx plus b, but we're not going to use y or x. We're going to use the variables in our particular experiment or our particular graph. So in this case, I have pay on my y-axis equals whatever my slope is times time, which is on my x-axis, plus my y-intercept. Now, if I'm an hourly employee, I would expect my y-intercept to be 0, meaning if I work 0 hours, I make 0 money, which is why I put plus 0 here. And in this case, my slope is my rate of pay. So this would be 11.5 would be if I made $11.50 an hour. Okay, and so that's what you would have your equation look like. Pay equals 11.5 times time plus 0. Just as a little side note, if you do have a directly proportional relationship, it will go through the point 0, 0. It is a special type of linear relationship. You can have linear relationships that don't go through the point 0, 0, and you would not call them directly proportional. You would just call them linear. Okay, so if you want to add that little side note. The third type of relationship you need to know is an inverse relationship. For example, how does my speed affect the time it takes me to get to my destination? And I would expect that if I drive faster, I will get there in less time, meaning that as my rate of speed gets larger, my time gets smaller, and they change in opposite directions. This is going to be indicative of an inverse relationship. The two variables are interrelated, but the change of one causes the opposite change to the other. This relationship can be described mathematically like this. And if you haven't seen this symbol before, I don't know whether or not you've seen this in your math class, this symbol means is directly proportional to, as opposed to is equal to, because it's not equal to 1 over x necessarily, but it is proportional to 1 over x. So that in an inverse relationship, I would say that my y variable is directly proportional to the inverse of my x variable, or y is proportional to 1 over x. In this case, that's time is proportional to 1 over speed, or you could write it like this, the inverse of speed, speed to the -1, same thing. Okay, but that is how you would write out that relationship. Now, that's not an equation. That just is something we can use to help us see the proportionality. If I double my speed, I would expect my time to be half. Okay, now we could get an equation from our data, but not like this. I'll show you how to do that more tomorrow. The fourth type of relationship is a squared relationship. This is one you should be familiar with. I picked an example everybody should know. How does the radius of a circle affect its area? Okay, and you should know that because the equation for the area of a circle is pi r squared. Therefore, the area of the circle is directly proportional to the radius squared. So this is a squared relationship. If you were to graph it, your graph would look something like this. So our squared relationships are going to have an upward facing curve. In a squared relationship, changes to the x variable cause an ever increasing change to the y variable, of course, because it is being squared. So you need to understand those proportional relationships as well. If I had a circle, for example, with twice the radius, then I would expect the area to be 4 times as much because it is radius squared, proportional to that. Okay, so again, this is the fourth relationship. The last one that you need to know for this class is a square root relationship. Okay, and for example, how does your height off the ground determine how far away you can see? So if you were to somehow be able to measure your sight line, how far you could see as you went to taller and taller buildings or up a mountain, whatever. As your altitude increases, you should be able to see farther. However, that does taper off. There's only so far you can see. So it might produce a graph with this type of shape. Maybe that's a square root relationship. Okay, I would say that means that y is proportional to the square root of x. You could also write this as y squared is proportional to x, which of course you would get by squaring both sides. Okay, so that is another way of writing that same thing. In my graph, that would be height is directly proportional to the square root of altitude. And in a square root relationship, that means that as your x value increases by a fixed value, that your y value is increasing by an ever decreasing amount, because of course it's increasing by the square root of x. So you're going to see a lot of these graphs throughout the year, either ones that you draw yourself from data that you collect or data that's provided to you that you have to analyze on a test or whatever. Okay, and the way that you identify these relationships is usually by just looking at the shape of the graph. But sometimes those graphs are harder to tell what they are. Okay, so side note, some of these relationships are harder to see. So if I were to show you this, or this, or this, those all look pretty much the same. Okay, but one of these is 1 over x, one of these is 1 over x squared, and one of these is 1 over the square root of x. Okay, so we're going to talk more tomorrow about if you think it's inverse, how do I prove that it's inverse and not one of these other things? Okay, so that's more for tomorrow, just to lead into that. But for today, for the rest of the period, you're going to be working on an activity in which you're going to be gathering your own data so that you can plot your own data, so that you can look at the shape of your data and figure out what you think the relationship is for your experiment. You're going to be getting into groups of 3 or 4 in just a moment to complete this kind of mini lab. And you're going to be doing one of 2 labs. You're only doing one of the 2, and I'll assign them to you once you get into your groups. But you're either doing a lab called swinging stuff or a lab called keeping it level. If you end up doing keeping it level, then your materials are back here in this corner of the room. If you're doing the swinging stuff, your materials are back there in that corner of the room. So once I tell you which one you have, you're going to go back there and you're going to want to grab one of each of those pieces of equipment. And then there's also papers back there with your instructions. Each person needs their own paper, so please make sure that you grab one and that everybody else in your group grabs theirs as well. Your task is going to be to gather all your data today so that you're able to produce a graph that we can then analyze more tomorrow as we go through some more of our notes. So there is a spot for you to graph your data on the front of the page, and then you can answer number 2 on the back. Before we get any further into this, though, I'm going to give y'all a second. I need you guys to get into groups. So find yourself a group of 3 or 4. Half of us, based on the size of this class, are going to be in groups of 4, and half of us are going to be in groups of 3. So I should have 4 groups of 4 and 4 groups of 3. So go ahead and do that. I'm going to give you a moment to get into a group, and then I will assign you one of these, and we can talk a little bit more about what you need to do. Everybody should have some supplies now that I've assigned you a group. Attention up here for just a moment. Okay, because what I did is, why did it go up there? I took some pictures last period, but this is kind of what the setups end up looking like for keeping it level and for swinging stuff. Okay, so you can see what that setup's going to look like, but read your instructions. Okay, now if you are doing keeping it level, you also need to open up Schoology because you have some instructions on how to use a force sensor. Those instructions are not on the page. You have to connect a force sensor to your computer. So somebody needs to open up Schoology to read those instructions, and that person can either connect it to their computer or you can get somebody else to open up their computer. They can connect it while the other person reads the instructions. Okay, but again, your setups are going to look something like this. This is from my last class. All right, so go ahead and get to it. You have the remainder of the period. You need to gather the data today. If you don't get all the data, you won't be able to do the stuff tomorrow. If you have questions as you're gathering your data, please let me know. If you're still working, keep working, but I do want to just give you a heads up that you only have about 7 minutes left, so hopefully you are nearly finished with your data collection. If you are finished with your data collection, then you can go ahead and graph your data at the bottom of that page. according to the graphing rules we talked about yesterday. And then at the top of the back of the page, there's a question that asks you to predict what your relationship is. And we just went through the different relationships and you looked at the different shapes. So you should hopefully be able to make a prediction there. However, you can stop after that. We have not talked about the rest of the stuff. That's what we're doing tomorrow. Okay, so again, get the rest of your data, and then we will come back and talk about the rest of this tomorrow. As a reminder, you do have homework. Intro due today, primer due tomorrow, skills packet Monday. This mini lab is not homework, although I would do the graph. Bring me your signed paperwork, get your safety contract signed.